This question was responded how to recognize the paraconformities. Now we are going to see the genesis, where they are produced, how they are produced. Paraconformity can be found in marine deposits. Does not mean that all the marine deposits will have paraconformity, but there is a chance. It may be possible when layer A was deposited, after that without much break layer B was deposited. Draw a cartoon hill from where the sediments are coming and going to the marine basin. Somehow the supply of sediments gets stopped, and then again it starts after possibly few tens of thousands of years or millions of years. In that case, layer M will come with a significant time gap between M and B, leading to a paraconformity situation. I repeat, in case of paraconformity, here no erosion took place or no erosion is characterized. While discussing the unconformity, we need to also refer a term known as diastem. This word is found in the geological literature, and it indicates a type of unconformity, but where a shorter time gap is represented. I have already discussed the major kinds of unconformities. There are few other terms which you will find in the literature. One is known as the blended unconformity. And erosional surface is not clearly defined. And it develops when erosion and deposition happen simultaneously. In some literature, the BU or the blended unconformity has been considered as a kind of non-conformity or a disconformity. Non-conformity or the disconformity. So, how it will look like, how the blended unconformity will look like. Previously we were marking a clear unconformity and then there are other layers above, but such sharp unconformity plane will not be found in case of blended unconformity. Not only erosion was happening, but when materials were eroded out, deposition was also happening together. So, such sharp unconformity plane is not visible in case of a blended unconformity. Now, we will look into the buttress unconformity. It is also called on-lap unconformity. This word on-lap and similar other terms will be found when I discuss sequence stratigraphy in detail. Here, in case of a buttress unconformity, Beds of younger sequence were deposited in a region of significant pre-depositional topography. Young sediments deposit on a pre-depositional topography. So, one can think, let us say, shallow sea in which there is a bedrock is old and there sedimentation happens. So, if I make a sketch, say this is the sea area, this is the land area, and here sedimentation happens in the shallow sea region, first layer A, then layer B and then layer C. So, here this contact itself marks the buttress unconformity B dash U. So, what is happening here? The younger rocks A, B and C are at an angle to the buttress unconformity. Let me write down. A, B and C are angle to the buttress unconformity. And here what is the old rock? We have mentioned young rock or younger rock. What we mean by the old rock here is this land, and whatever is the rock material here we can designate it as the old rock. So, what has happened, if we put in a different word, the younger unit A, B and C got terminated at an angular relation with the buttress unconformity. They get terminated with an angular relationship. Rocks below this unconformity, the buttress unconformity, may not be parallel to this buttress unconformity. We have so far not said anything about the layers in the old rock, whether they are horizontal or inclined, they can be anything. So, there is no guarantee, and that is why I have not in fact drawn the layers, whereas I have drawn the horizontal layers over here. So, what is the difference if we pose a question now, what is the difference between angular unconformity and the buttress unconformity? If you go back to my lecture on angular unconformity, you will find that below the angular unconformity, layers are at an angle to the angular unconformity itself. These layers A, B, C, D, E and their lithological contacts are at an angle with the angular unconformity, whereas in case of a buttress unconformity, this is the land, this is the ocean, and say there are deposition of layer A, B and C. These are the younger layers. So, the younger layers are at an angle with the buttress unconformity. This is the one of the ways of telling the difference between the angular unconformity and the buttress unconformity. In the context of unconformity, you may come across a term called conformable contact. What does this mean? When there is no significant age difference between different layers, say this is layer A, then layer B and layer C, there is no significant age difference. It is not that the age difference between A and B is millions of years or thousands of years or even hundreds of years, not even that. In this way A, B, C etc. are having mutually conformable contact. A, B contact is conformable. Or another language can be seen in the geological literature, that is A, B and C got deposited Okay, what is the major use of unconformity in geoscientific studies? Unconformities now play a key role in definition and mapping of sequences. Based on unconformity, we can define sequences, and I repeat, this word will come back when we describe the sequence stratigraphy in detail. And just for your information, this word unconformity was used in geology for more than 100 years. One way to look at the development of any subject is to look at the history of that subject. In this way, there are some research papers which describe the historical development of the concept of unconformity, and the oldest reference goes more than 100 years back. In this lecture, we are not getting into the historical development of these subjects. Even if we do, that will be very short here and there in other lectures. Now, with the modern concept of plate tectonics, we have tried to look at unconformities, and we understand that there are 4 major classes of unconformities. What I am going to describe here can be called as a modern concept. Number 1, there can be an unconformity that indicates major break of 10 to the power 6 to 10 to the power 7 years. Of how much time? 10 to the power 6 to 10 to the power 7 years. Just to recollect, 10 to the power 5 is lakh, 10 to the power 7 is crore, 10 to the power 6 is million, and 10 to the power 9 is billion. So, when I say major break of 10 to the power 6 to 10 to the power 7 years, this means that 1 to 10 million years. Now, what can be the reason of such unconformities being produced? One can be linked with orogeny or tectonics. The reason of such unconformity giving major hiatus or break in deposition sequence can be orogeny, which means mountain building process, or tectonics. Such unconformities can be linked with the tectonic movement, the basin formation, sedimentation initiation, etc. Then we can also write like orogeny tectonics, basin formation, and when we say basin formation, one of the ways can be rifting. All these can be linked. All this can produce in some cases major unconformities giving 1 to 10 million year time gap. The other reason can be global eustasy. Eustasy means sea level change. If that is happening, it can also produce major break in deposition. Now, we will look into the second variety where there is a shorter time gap indicated, which is 10 to the power 4 to 10 to the power 5 years. So, this is certainly less than 1 million. Just to recollect, 10 to the power 6 is 1 million. So, we can write this as 0.1 to 1 lakh years. Note that the units lakh and crore works in South Asia, and those who stay in the Western world will not be much aware of these terms. Lakh and crore you will find relevant in India, Pakistan, Sri Lanka, Myanmar, Nepal and Bhutan and few other countries. What can be the reason of this shorter time gap in giving unconformity? Without getting into the detail, I can write down high frequency tectonics and global climate change. We always hear that at present we are facing the global climate change. Does it mean that anywhere in the world a new unconformity is produced? Remains an open question. Third, a hiatus of 10 to the power 0 to 10 cube years. So, the reason of such very short in the sense of 10 to the power 6 to 10 to the power 7, these are large. In comparison to 10 to the power 6 to 10 to the power 7 years, 10 to the power 0 to 10 cube years is certainly a short time range, and it can be produced due to seasonal changes or long term geomorphic processes. This 10 to the power 0 year means 1 year. And what is the meaning of seasonal change? Every year, let us say during rainy season the deposition happens, and in other time the deposition does not happen because no erosion takes place by the flowing water. So, every rainy season deposition takes place after every 1 year. So, in that way the seasonal change word is explained. Seasonal change cannot take care of, or yearly change cannot take care of any major breaks that happen or any break of 10 to the power 4 to 10 to the power 5 years. Now, we will look into the fourth one, which is the minor breaks in time. Such as 10 to the power minus 6 to 10 to the power minus 1 year. So, this means minutes to months. The example can be the beds produced by bed forms and bar migration. Now, it can also be produced by monthly or lunar and meteorological changes in runoff, such as the tidal cycles. Let me write down monthly, or it may be lunar and meteorological changes in runoff. We can also refer here the tidal cycles. Okay, now we are going to see important features associated with unconformities, and in fact these features help us identify the unconformities. We will discuss paleosols, and in this connection also we will talk about the bowl beds, and we will talk about the basal conglomerates. And right now we will start with first the paleosols. Imagine layer A and B got deposited. Now there is a time gap in deposition and this surface was exposed to atmosphere. So, soil has formed, and after that new deposition starts and leads to deposition of unit P and Q. Now, after thousands years or after a million year, we are identifying this soil and we are calling it paleo soil, just like soil. Paleo means of the past and we call it as paleo soil. Now, obviously, this paleo soil, when it was deposited and the present time, there must have been some chemical alterations because groundwater leaching, groundwater movement might have changed the chemistry of this paleo soil. So, its chemistry may change from its initial one. These paleosols are mostly found in sedimentary rocks. However, old Archean rocks also have documented paleosols. Now, the paleosols formed indicate a long time range of stability of landscape. Let me write down. Paleosols indicate or imply in the past stability, tectonic stability happened. Because to form soil, we need protracted time for the rocks to be exposed with the atmosphere. So, once we find paleosol, we understand for a long time it was in a stable condition and no further deposition was taking place, and then after a lot of time again deposition started. Now, various classifications of paleosols are there, but we can, for the beginners, refer to a simple classification. Number 1 is called the buried paleosol. The second one is called the exhumed paleosol, and number 3 is known as the relic paleosol. Exhumed and relic soils can be identified with confidence if they are correlated with buried soil elsewhere. These two soils are difficult to identify because they get lot of alteration. Exhumed one is now exposed to the surface, so surface water can alter its chemistry. The relict one, in the past already it got altered. So, if somewhere we have a confirmed paleosol and we find a chemical resemblance between that and the exhumed paleosol and the relic paleosol, then their identification becomes easy. Otherwise, certainly they are difficult to identify. Now, one may consider the bowl bed similar to the concept of the paleosols. These bowl beds are, let us write down about the bowl beds. Fine grained clay or earthy materials and the color can be red. So, it is then known as the red bowl, or green, we call it green bowl. It can be gray, several other colors are possible. purple, brown, we can write chocolate brown, etc. So, between two lava flows, if there is a time gap, there can be bowl bed, can be present between two successive lava flows. What does this mean? This does not mean that the lava flows happen one after another, but there was a significant time gap, the bowl beds were produced. Now, where do we get bowl bed? In Deccan Trap, giving Indian example, we find the bowl beds. If you go to the Pune city, at places you can find, even inside the city, whatever the exposures of Deccan Trap rocks are there, very thick layer of red bowls. In Mumbai, there are many places where thin layers of bowl beds can be seen, such as if one goes to the Kharghar hills, bowl beds of different colors can be found out. In some places, it has been seen that the bowl beds have slightly lower pH. Bowl beds in few cases have slightly lower pH, significantly lower electrical conductivity, and much lower organic matter content. Than the modern soils. Why so? Because when the proliferation of organisms have happened, after their death they become part of soil. So, the carbon content is naturally very high. This is certainly not the case with the very old bowl beds. The paleosols can also be described as fossil soil horizon. And sometimes these fossil soils are preserved as thin bands of aluminum rich metamorphic rock sandwiched between metasedimentary sequence, but that may not be in all the cases. So, I am not writing that. The kind of chemical enrichment in the paleosoil usually differs from the country rock. We will now see the basal conglomerate, which develops sometimes along with the unconformity over the unconformity plane, but they are not always developed. For that, we can go back in the slides and we come to the case of a disconformity. In case of a disconformity, there we can find conglomerates, which is recognized as the basal conglomerates, and there is a view that these conglomerates are basically broken clasts coming from the rocks at the bottom of the unconformity. Probably these are the broken clasts contributed from rocks below the unconformity. Now, these basal conglomerates in few cases in the world have been found to be enriched in uranium. This basal conglomerate may be enriched in uranium. There are some reports of gold enrichment and nickel enrichment as well. There are some giant uranium deposit also of this kind, which is linked with the unconformity. The word unconformity will also find use while describing the hydrocarbon traps, and this term will be found unconformity trap. Let us try to understand. Let us consider an angular unconformity. Imagine over the angular unconformity, this layer N has low permeability. What is permeability? Just to recollect, it is the ease of fluid flow through a medium. Permeability small k is proportional to square of the grain diameter. D is the diameter of the grain. So, this indicates smaller the grain size, very much reduced. This indicates when grain size is reduced, the permeability is significantly reduced. In other words, shale, clay, these materials, these sedimentary materials have got very low permeability. Now, come back to the angular unconformity situation. Suppose here we have shale or clay deposition, they are fine grained, D is small, so K is very low. Low permeability means very low potential of fluid flow through them. So, these low permeability material can act as seal, precludes, that prohibits the fluid flow. Now, imagine from bottom hydrocarbon is coming, being of lower density, it migrates up through some pathway, either fractures or interconnected pore spaces, and then the hydrocarbon gets stuck here. It cannot move further up. What is the reason? It cannot move up because we have a low permeability seal material present. So, in this case, this unconformity is stopping the fluid flow, which is what is the exact reason? Not this surface, but the kind of material that has been deposited over there, what nature has deposited. So, such a trap is known as the unconformity trap.